Good morning. We're going to start a new unit today. So technically, our first unit and our 0 unit kind of combined. So if you want on that table of contents, you could write where it says unit 0, you could squeeze in there and 1, because technically we did them together. We did not take a unit 0 quiz like we usually do. That's because it was right around map testing time. So we just kept going. Did unit 1 because everything in unit 0 is embedded everywhere else. So we'll pick it up along the way. So we're starting unit 2, exponents. So you're going to fill this in. This goes on page 11. So I wrote it here, but I made it big so you can read it and see it. There, I'll zoom in. So page 11 should be your table of contents, this paper right here. If you do not have this paper, you could either fill it in on your own or wait till we eventually go back to school together and I can give you the paper. But I hope Tuesday or Wednesday, I hope we're back in class. Then we're going to have our learning guide. Now, if you were in class, you have one of these. That learning guide looks like this. And it's only on half the page. That way you can trim that down. So this might be a nice scratch paper. We're going to use some scratch paper today to visualize some stuff. So if you want that, use it. If not, recycle it. And this is for unit 2. So you may need to do a little edit there. Notice I put the 2. Yep, it's now unit 2. No longer unit 8. So this is what we're going to go over. Yep. We go a little bit out of order. We don't go in this order per se, but those are our 3 main learning targets for this unit. So it is a quicker unit than last unit. This is a tough unit. And then we have our exponent rules. This paper is going to be very important. These rules get a little tricky. So we're going to go through each and every one of them, and I'm going to show you how and why they work with a little extra work. That's where that scratch paper might come in handy. So here we go. If you got these notes, great. If not, you can do it again on a scratch paper if you want, or you can do it through Cami and do your notes digitally. We're figuring this out. We're doing whatever works for us. So I drew this thing at the top here. This is kind of a helpful hint that I use. This is how my brain works with these rules. So I'm going to show you that. I'm going to also show you the actual rules and why they work. But I did it with the operations. So addition and subtraction are at the top. Multiplication and division are next. And then we have our exponents and our radicals. Yes, that is a square root symbol, but also known as a radical, because it could be a cubed root, 4th root, 5th root. We'll get to those. Okay, so if you want to draw that at the top, I'm going to refer back to that. You can pause, do that, catch up. So adding and subtracting monomials. You've done this. This part's easy. It's just combining like terms. Do not change common variables and exponents. They stay exactly the same. So if I gotta move my face. Okay, there we go. If we look here at number 1, we have 9x squared y minus 10x squared y. We can only combine if they have the exact same variables with the exact same exponents. Well, we do have, in fact, an x squared in both and a y to the first power in both. So they're exactly the same. It's a lot going on, but we can just take our coefficients and combine them. So we can just take this 9 and this negative 10, watch out for that, negative 10, to combine to make it a negative 1. So we can write negative 1x squared. Notice I said it, but I didn't write it. We don't need that 1 out front, but it's an option. There we go. We combined our like terms. Now be careful with this next one. It says subtract 6w from 8w. Remember, subtract from, less than, fewer than, So if we're subtracting 6w from 8w, 8w is first. And we are subtracting 6w from that 8w. Right, writing expressions, it's coming in handy. There we go. So if we have 8 waffles, then we eat 6 waffles. How many waffles are left? Well, we only got 2 waffles left. Ta-da! I guess we could have put equals Easy. That part's not new, but it's something we're going to need. Our next rule is called the product rule. Product is the answer to a multiplication problem. Notice that's multiplication between two exponents. Wonderful. So our product rule goes like so. Draw it on here. So we have x to the a power times x to the power of b. You can say it either way. So what that's going to do is we can have our x, since it has the same base, both of the bases are x. This is an x, this is an x. What we can do is we can then add our exponents. So it'd be x to the a plus b power. Now I'm going to talk about my special hint up here. So when we do our product rule, that is multiplication. What we do to our exponents is that lower level of addition. Maybe that helps, maybe that doesn't. So if we multiply our bases, we add the exponents. Okay, let's look at why and how in our first example here. Let me move my face again. There we go. So if we look at this, I'll do it the rule way, and then I'll show you broken down why we get that answer. So if we have h squared times h to the sixth power, our bases are the same, they're both h, so that stays there. Since it's our product rule and we are multiplying, we can do that lower level of addition to our exponents. So we'll have 2 plus 6. Notice that's exactly what we did here. We had our x to the a times x to the b, so we had x to the a plus b. Same idea here, same format. And then we can actually simplify that because I know you can add those like terms. 6 plus 2 is 8. Now, what is happening? What's going on? I'm going to show you on a little scratch paper here just because there's not quite enough in here. Dun-dun. So we had h squared times h to the sixth. If we break that down, h squared is the same as saying h times h. And then we can multiply that times h to the sixth, which means we have 6 of those h's. 1, 2, 3, 4, 5, 6. From there, that's all multiplication. I showed it with the dots, I showed it with the parentheses, but it's all multiplication. So we can combine all of our variables here because we have 1, 2, 3, 4, 5, 6, 7, 8 h's. That's where we get our answer. So this is broken down. This is one of the best methods. Students really use it. It helps visualize it, helps to see it. So if you ever need this, use it. It's good stuff. Okay, next, number 2. Well, if we look at number 2, I'm going to zoom in a little bit here. We have a negative 2a squared b times 7a cubed b. I'm going to do it with that broken down method. So we're going to break everything down. So here we have a negative 2. Cool. There it is. We have a squared, which is the same as saying a times a. Good. And then we have our b. It's just b. That's why we kind of talk about it's. I mentioned it before that b is to the first power because there's technically only one of them. That's another one of those invisible one. It's just kind of, we don't write it, but it's always there. So I'm going to put it so you can see it. Times 7 times a cubed, which means we have a times, that is 1b right there, so it's b to the first power, so it's just b. From here, we can kind of regroup using that commutative property of multiplication. So we have our negative 2 times 7, which would give us, and I'll change my color for the answer, a negative 14. And then we have our a's next, right? Alphabetical order for variables. A's go next. We have 1, 2, 3, 4, 5. This would be a to the fifth. then we have two b's, so it'd be b squared. Now, if we look what we did here, a squared times a cubed, we can do that if we just had, that would be a to the 2 plus 3. And look right there, 2 plus 3, 5. So you can use it using the product rule. You can use it breaking it down. Your choice of method, it's that same idea. Just watch out if you're using that rule, that's not b to the 0 power. It's b to the first power because we have one b sitting right there. So we have b to the first and b to the first, which would be b to the 1 plus 1. Look at that simple math. Ooh. So we have 1 plus 1 is 2. There's the 2 right there. It's a little weird, but not so bad. Okay, next. Our power rule. Powers are like exponents, so it's our power rule. We have an exponent to an exponent. That's a thing. So when we do this, again, I'm going to go back up to my helpful hint here. So when we do this, what we're doing is we're going from exponents, and then in the exponents of the exponents, we do our lower level of multiplication. So what that means down here is our x to the a to the b will be x to the a times b. Let's write that a little bit prettier, shall we? Because I realized that that's not the best mathematical way to write the multiplication. Now, if you've already done it in pen, you can write this next to it. So it'd be x to the a times b. We write them right next to each other to show multiplication. That's our highest level there. So kind of see that lower level idea. It'll work for all of it. Okay, here we go. So let's, oh no. So let's look at one of these here. So we have x squared cubed. Use that rule. We have our x, okay, cool. X, and then we have, since it's to a power, we do that lower level of exponents, and we multiply our exponents. So up here we would have 2 times 3. There we go. We wrote it like that, which gives us x 2 times 3, 6. Now, why does that work? How does it work? How do we break it down, Miss Eisword? Here we go. So for this one, we have, I wanted to change color. We had x squared cubed. All right. So we have x squared in there. We know that x squared can be written as x times x. We have 2 of those x's, and it's cubed. Okay, well, that entire x times x is cubed. We have 3 of those. So if we write that all out, we have 1, 2, 3. That's all multiplication, whether it's dots, parentheses. How many x's do we have? 1, 2, 3, 4, 5, 6. So we have x to the 6th power. Ta-da! So make sure if you're getting stuck, break it down, draw it all out. It helps. Okay. Next one. Here it gets a little tricky because we have 2 rules going on. We have our power rule and our product rule. We're going to take care of our power rule first because back in order of operations, exponents are first. Okay. So the other thing is we also have distributive property in here. This squared is going to go to this m to the 5th power, and it's going to this negative 2 to the 1st power. It gets distributed. Just like we distribute multiplication into that lower level when there's addition in the middle. Same idea with exponents. That squared can go to everything that's being multiplied together. Okay, the same idea. It's coming back around. New things. So what we have here is we have a negative 2 squared. Now, the entire negative 2 is squared because that negative 2 is in parentheses. So that's a good one to keep those parentheses around it. That way you don't mess up your sign because it's a negative 2 times a negative 2, which is going to make a positive 4. Okay, so our next one, we have m to the 5 to the 2. So if it's a power rule, we do that next lower level of multiplication. 5 times 2 is 10. And then we have times m cubed. This m cubed is just tagging along for now. We took care of our power rule. Done. We still have a few more things, like let's simplify our exponent there. So we have negative 2 times negative 2, which is positive 4. Okay, we have an m to the 10th power times m to the 3rd power. So since it's multiplication for our bases, we do the lower level for our exponents. So we're going to add our 10 plus 3, which gives us 13. Ta-da! We've simplified our expression as much as we can. Those rules aren't too bad. Now, we have our quotient rule when we deal with division. Okay, back up. If we are dealing with division, remember our little helpful hint up here. If we are dividing in our bases, what are we going to do in our exponents? Subtract. That next lower level. So what this is going to look like here is that we have x to the a divided by x to the power of b, which will give us x to the power of a minus b. I'm telling you, that lower level, it works. It's good stuff. Okay, here we go. Now, we know what to do with our exponents, but a lot of students will freak out. But we have a 27 and we have a 42. Okay, that's a 27/42. Treat it like a fraction. So we can simplify that fraction, and we'll talk about how and why and what when we break it down in a moment. But if we treat that as a fraction, 27 and 42, they can both divide by 3. How do we know that? Well, we can add our digits, the divisibility rule. If we take 7 plus 2 is 9. 9 can divide by 3, so can 27. 4 plus 2 is 6, which can divide by 3, which also means 42 can divide by 3. So there's divisibility rules help for quickness. So we can just simplify that. 27 divided by 3 is 9. Oh, that's a scary looking 9. Here, let me do it like this. There, that's better. 42 divided by 3 will give us 14. Okay. We just treat it like a fraction. Now, our exponents, we're going to use our rule. Since we are dividing x to the 5th divided by x, how many x's do we have there? 1. We just have 1 x. Keep in mind that is always a 1 x sitting there. Okay, so we have 5 minus 1 is what we're going to put. So I'm going to write it out so you can see it. So we have x to the 5 minus 1. And I always suggest writing out the division ones because sometimes we get minus a negative 1. So watch out for the double negative. Sometimes we have a negative number minus another negative number. So always write it out so you can see it so you know what integer rules to use. Okay, but we can simplify that subtraction to be 9 x to the 4th over 14. Now, you want it broken down? I'm going to show you breaking it down with the variables and the coefficients. Here we go. We have, I have it right here. Okay. Okay, here we go. So let's break it all the way down. We have, first let me write it, 27 x to the 5th all over 42x. I'm going to break everything down, including our numbers. I'm going to break those numbers down into its prime factorization. What is prime factorization? You can call it trees. 27 can split into two factors. 9 times 3 is 27. Oh, look, 3 is prime. 3 can only divide by 1 and itself, so that one stops. That branch of the tree stops, but the 9 is composite. That can still get broken down into factors. 3 times 3 equals 9. Oh, look, there's our prime factorization for 27. So in my numerator, I'm going to have 3 times 3 times 3. Whoosh. And how many x's? We have 5. Times 1, 2, 3, 4, 5. Okay. So that was our first tree. Might run out of room from a second tree. No, I might be able to fit it. Okay, so let's break down 42. 42. One of the easiest. It's even. It can divide by 2. So 42 divided by 2 would leave us with 21. Cool. 2. 21 can split into 3 and 7. Both are prime. There's our factor tree. So 42 could split into 2 times 3 times 7. Now, if you're wondering, wait, what do you mean 42 can split into 2 times 3 times 7? We broke it down into its prime factorization. If you multiply 2 times 3, 6, 6 times 7, 42, you're going to still get the answer. We've just broken it down into its prime numbers. Just kind of like how we did the x to the 5th, and we broke it down into all its primes of 5 x's. Okay, then we just have one x. Oh, look, one x. I drew it. There it is. Okay. So from here, we know that if we simplify and we divide things, they cancel out. They're gone. Because anything divided by itself gives us 1 as an answer. So if we look, we have 3 divided by 3 is 1. So those are gone. Nothing else. We can't do the 3's in the same numerator. It has to be the numerator and denominator. We also do have x's, though. How many x's? Just 1. X divided by x leaves us with 1. Okay, that's all the simplifying we can do, so we can regroup now. Notice the regrouping is our answer. So if we have 3 times 3, actually, I'm going to write it to the side here. I'll just write it down below. So 3 times 3 would give us 9, and we have 1, 2, 3, 4 x's, so we have x to the 4th. Over 2 times 7 is 14. That was our answer. So that's how we can break it down here. So those rules are the easier ones. This next one gets a little weird. But before we get to the weirdness, let's finish up our second example of the easier ones. So we're like, the easy ones, this is weird. Yep, it's weird. Okay. Ooh. We have a few different things happening here. We have y squared to the squared, all divided by y to the 4th. Order of operations, we have to do our grouping symbols first, so we're going to group that numerator together. So we're going to do our power rule first, and then use our quotient rule. So again, we're mixing some of the rules from above. So let's get that numerator done. So if we just write it here, we can just write over y to the 4th. We're going to leave that there. If we have y squared to the square power, to the second power, sorry, my words, we're doing that lower level of exponents, so we're going to multiply. So 2 times 2 gives us y to the 4th. Some of you are already seeing it. Some of you know what's going to happen. I'm going to show this to you with the rule here, and we'll break it down on the other page. So if we go with our rule, the rule that's right over here, if we're dividing, we do that next lower level with our exponents, and we subtract. So we're going to have y to the 4 minus 4. Okay, 4 minus 4. So we will have y to the 0 power. We've never had something like this. What do we do? Well, we're going to go one more step. Now, this rule is technically at the bottom. But let's see if we can figure out this 0 rule with breaking it down. So I'm going to go back to my other page and break it down from the y to the 4th divided by y to the 4th to see if we can figure out what our answer is before learning the rule. Okay, here we go. So we have y to the 4th over y to the 4th, which gives us 1, 2, 3, 4. 1, 2, 3, 4. Now, just like last time, right, we divided things out. So if we look back up at the top here, the same things divided out because they divide to give us 1, right? If we had 3 divided by 3, that's 1. 1 times anything is itself, which is why we didn't write the ones. There's a lot of ones that we don't write. So if that is therefore true, we have y divided by y divides out to be 1. Y divided by y divides out to be 1. Y divided by y divides out to be 1. Y divided by y divides out to be 1. So technically everything cancels out and we're left with 1. Be careful, it's not 0. Why is it not 0? Remember that 3. If we had 3 divided by 3, it gives us 1. It's that multiplication, division. It's not adding and subtracting to be 0. Multiplying and dividing. Watch out for that. Same thing, just like if we had 4 divided by 4, gives us 1. Anything divided by itself gives us 1. Therefore, y to the 4th power divided by y to the 4th power gives us 1. So if we look back, that rule is anything to the 0 power gives us 1 as an answer, which is a poster in the classroom I would refer to, but I'm not there. Okay, so I would skip to that rule at this point, but let's get to our weird one first. This one, let's just put a star by it. This is the weird one. This is the one that's a bit of a struggle. Okay, so just keep that in mind. It's weird. So here's what's going to happen, and then we'll talk about it. Negative exponents, we can't have those. We got to take care of them. So how do we take care of them? Great question. They're unhappy. The x to the negative a is unhappy. So in order to make it happy, we just throw it in the denominator. Now it's happy. So it's kind of one of the ways I think about it, is that if it's a negative exponent, it's not happy where it is, and it has to move to the other side. Now, some of you are like, other side? There's no other side. What do you mean side? Ooh, here we go. Anything has a denominator of 1. Anything, we can write a 1th under it, because anything divided by 1 is itself. So if we put that 1th here, notice, it just like flips it. It's just, and I always struggle with this because there are teachers who teach it where if you have a negative exponent, it always goes to the denominator. Okay, well, kind of true. Issue is if that negative exponent is already in the denominator. It doesn't get thrown back into the denominator. It's already there. It's already unhappy. So if we happen to have something like that, like if we had, let's say, 5 over x to the negative 2, it's unhappy in the denominator. So what we do is it just gets moved to the numerator. So for this one, we would just have 5x squared. I mean, we could put the 1th. Do we need the 1th? No. So it just moves to the other side is what I think about. So it's unhappy where it lives. Move it, it's happy. It's a positive now. It's more of a trick, not really a rule. Okay, so let's try some of these weird ones. Now we have a negative 5x. That's like the one I almost just did. Almost, not exactly. Okay, so remember we talked about that one. Okay, so we can give ourselves a 1 to help us visualize. Negative 5 is just a negative 5. We can have negative numbers. That's fine. So our negative 5 is just fine right there where it is. X to the negative 2. That's the one we got to fix. We can't have negative exponents. So those negative exponents, it's going to just change to the other side. So we take that x to the negative 2 power. If we bring it into the denominator, oh, look, it's happy. Weird? Oh, yeah. The toughest rule? Yep. Now, some of you are like, wait a minute. Number 2 doesn't have a negative exponent, Miss Heisberg. What are you doing? Okay, let's simplify as we did last time here. So with our fraction, we have 4/8. What can 4 and 8 both divide by? Okay, 4 and 8, they can both divide by 4. 4 divided by 4 is 1. 8 divided by 4, 2. So we just simplified that fraction of 4/8 to 1/2. Ready to go. The next one is k. Okay. K squared divided by k to the 5th. Ooh, we have division. Okay, so if we look at our quotient rule, we do that next lower level of division and we subtract our exponents. So we're going to subtract our exponents. Okay, so notice the order. We're going to have k to the 2 minus 5. Ooh, that's a nice 5. Now, as you're looking at this, did we need to write that 1 in the numerator? No. I'm going to leave that in the work. I won't put it on the next one. The 2 we needed. I'm going to move my face again. Okay, there we go. So what we have here is we can simplify k to the 2 minus 5. What is that? Well, I'm going to leave the 1 for now. 1k. Okay. 2 minus 5, that gives us a negative 3. Oh, that's where the negative exponent is. Watch out for that. Okay. So then we have our 2 sitting down here. So we can put our 2 sitting down here. But we're not done. Oh no. We got to take care of that k to the negative 3 power. Okay. So here we go. We have 1k to the 3rd. That k to the 3rd is unhappy. So all we have to do is move it down to the denominator. So we have 2k to the 3rd power. Now some of you guys are like still like, what? Negative exponents? I don't get it. Okay. We didn't break it down. I'm going to break down this one because this problem has the better visual here. So we're going to break down number 2. I'll show you why the unhappy goes to the denominator. We'll see. So remember this answer. It's on your paper. Let's look. Okay, I have it written right here. Okay, here we go. So we have 4k squared over 8k to the 5th. All right, here we go. We're going to break it down. We're going to break it all down. So let's break down our 4 and our 8. Remember, just like we did with our factor trees. I'm going to break down 4 first. 2 times 2 gives us 4. Those are both prime. Then we have 8 can be broken down into 4 times 2. And then that 4 into 2 and 2. So the 8 has 3 2's. Next, we have our k's. We have k squared, which gives us 2 k's. We have k to the 5th. 1, 2, 3, 4, 5. Right next to my face. Okay. So remember the dividing out. So we have 2 divided by 2 gives us 1. 2 divided by 2 gives us 1. That 2 stays. There's no other 2 to divide with it. It's chilling. But we have some k's. K divided by k gives us 1. K divided by k gives us 1. Look where everything is. It's in the right spots. So there's nothing in the top. Now be careful. Nothing in the top doesn't mean 0. Remember, we divided out. 2 divided by 2 left us with 1. So we have 1 in our numerator. In our denominator, we have 2 times k, and there are 3 of those. So we have 2k cubed. That's why they end up in that denominator. There are more in the denominator than the numerator. So sometimes, here's what I like to do. I do 2 minus 5 is 3. That 5 is bigger, so the k cubed stays in the denominator. It's my brain. That's how it works. Okay, let's go back to an easy rule, because this one was crazy. All right, this rule will probably become your favorite. Maybe not. The zero exponent rule. We know there's special things with zeros and ones, and we already talked about that. Anything to the 0 power is 1. Because everything kind of cancels out just to be 1. It's kind of the thought process there. So now be careful with this, because some students are like, ooh, 7x to the 0 power is going to be 1. Okay. Only that x to the 0 power is 1. Right? So we would still have 7 times x to the 0 power is 1. What's 7 times 1? Oh, 7. So it cancels out anything to the 0 power, but the 7 is not a part of the base. Now, if it was 7x and then that was in parentheses to the 0, then the whole thing would become 1 because the 7 is to the 0 and the x. But that's not what we have. Remember, those in parentheses change the meaning, so watch out for that. There's no parentheses, so only the x is to the 0 power. All right, here comes a little review of some of the rules here, because as we know, the second one kind of mixes rules sometimes. So we have to simplify our product rule up here first. So if we need that product rule, we can always go back and look. What was our product rule? Oh, quotient. There we go, product. So if it's an exponent, we do that lower level of multiplication. So we're going to multiply our exponents. So we have w to the 4 to the 2. I feel like we can make a song out of that. Okay. 4 times 2 would be 8. Now we have 2 options at this point. You could simplify now. Anything divided by itself is 1. Or let's use our rule. So let's use our quotient rule. And since it is a quotient and we are dividing, we use that next lower level of exponents and we subtract. So x to the a power divided by x to the b power would be x to the a minus b. So we can take that w and have it as 8 minus 8. Seeing where I'm going here. So this w to the 8 minus 8 is 0. Anything to the 0 power is 1. It's 1. Just like some of you knew back here, w to the 8th power divided by w to the 8th power gives us 1. However you want to get there, your choice. I gave you little practice problems because I want you to practice just to kind of see how you're doing. I gave you the key. It says I gave you the key on the paper. Now, if you didn't get the paper, well, it's on Google Classroom as well. But this is me telling you, I gave you the answer key. So you're going to try the rules of exponents. And what it does is it kind of breaks it down. So I want you to try it. There's kind of a lot. So let's just do page 1, 2, and 3. There's not too many problems on there. They're very spread out. So I'm just going to do that. I'll fix that in the Google Classroom so it tells you, not just in this video. Sorry, this was kind of a long video, but it's a lot. It's good stuff, though. See you soon, hopefully.